used to it, I think, if you've already had it.
I don't know why I'm getting like 425.
I got some pretty bad error percentages though, like 25%.
With the most recent one?
No, the first one.
The first, oh yeah,
I got 50%
Yeah,
on
my
one.
percentage errors, were not so great, not so great.
I didn't know if I did something wrong with this turn in because I was.
No, I mean it.
Like, it was the same amount of like digits, so I felt like that, and it was in the
Tended to
sevens
not.
was the first digit, and that felt like that was pretty close to 8. So, given like I think it was that last question, like, what errors could have caused the percentage error?
I don't know, mine's like way off. I'm trying to figure out.
Is it
The
thousands of percents or even billions or?
Yeah, I got 425,000 for.
Mine wasn't too off, but it's because I
can't-
disagree with Dr. Fox on the
redoing
distance.
everything. I keep
And
arriving
because they
at
put a
the
different
same-
value for the distance, my answer
well,
was
when
like
I was
5% error.
starting to
These-
out numbers.
Like, do you know if these are reasonable values?
Like he said like 20,
Let's see, I already gave him
and I put like
mine.
21 or 22.
I
I
already
remember.
gave him
I
mine, but
I was expecting somewhere in the 10 to the negative 14th range instead of negative 13. I think you're off by a factor of 10 somewhere.
That's what, I know, but I just can't.
Like, those are okay.
did you do the like nanocoulombs to coulombs?
I did do that. That was one of my mistakes.
I had
It was
to email
yeah.
that. I was so confused.
I looked at my work for like half an hour and I'm like, oh,
I
that's what I
had
did
to- I
wrong.
had to talk to him about it, cause like
Yeah.
I spent like 12 hours straight on it, and I was so brain dead, like by the time I went to sleep.
Those things where you just spend so long on something and then it's
You just
so
have to take a
simple.
break and come back and reevaluate.
I redid all of my values and like I like reworked it and I was like re-looked at the lab. I just emailed him and was like, I don't know what to do.
I did that too, and I also had like Desmos pulled up, and I was like looking at all my calculations, and I'm like, what if I was slightly off on this number? And so I just like kept changing stuff around,
Huh.
and I'm like, this is getting worse.
And I kept
Nothing's
flipping the
coming out
graph,
of me
like
right
I
now.
kept flipping the values of the graph.
Yeah.
I did that too, cause I was like, oh, this doesn't look
The
right.
mass of the styrofoam. I think that's the mistake.
It's 0.0006 grams, or I have mine there.
Oh.
I think it's on the, somewhere around 0.6 grams, not 0.06 grams.
Or you should, yeah.
Oh
I think it was
my
0.6.
gosh.
It should
Yeah,
be
it's
the back
0.6
page.
grams.
Is that what it was? God
Yeah.
dang it.
What did you put?
Oh no.
Yeah, it was 0.0006 kilograms.
I was like, surely I could read the scale.
Surely.
God, I wasted so much time. Thank you, Professor Fox.
Yeah. All right, other questions?
Master set 25 question 1.
I'm probably gonna have to look at yours. Yeah, I don't have it with me. You have,
Oh, I didn't print it out.
I can pull it up.
That's what I was.
that'd probably be faster than Mike doing it on this thing.
I have it on my phone.
Oh, all right.
That works.
Yeah.
All right, so we got the electric field. All right, so for x less than, so that's x and y. Okay, is there a specific question or just in general?
In general, I didn't really get how to get like the area vector. The part about how there was like 2 electric fields really threw me off. Depending on x.
All right, so area vector. So if I have 3 meters by 4 meters, so area, it is a vector, so there's a magnitude
and direction.
Mhm.
The magnitude, just the simple, what's the area? So in this case, it would be 12 square meters. The direction is perpendicular to it. Because in order to define this, if we went up or to the side, that really doesn't help us because, we know the area of it, but we don't know. If we're going with the length, that means basically that area, the plane, the rectangle could be anywhere, sort of along that axis. So they decided to define the direction to be perpendicular to the plane, or to the surface. So if I define my I hat, J hat, and then K hat coming at us, the direction is gonna be either in the K hat direction or negative K hat direction. It's an open surface, so I have two choices, so it's plus or minus K hat. Pick one.
Wait, so you said it's, because it runs on X and Y, so for it to be perpendicular, it has to run along.
So, in that particular case, I had X equal to 3Y,
Yeah.
or Y is 1/3 X, so basically I have a line with looking something like that, if that's my X and Y.
Yeah.
And so the area vector would be pointing perpendicular to that.
Would it be perpendicular to?
Bless you.
It'd be perpendicular, so this is the plane right here that the electric field is hitting.
Okay.
So the area vector would be perpendicular to that, so it's either pointing in that direction or that direction.
And then the area vector would just be the dimensions. But
Yeah.
The magnitude would just be the centimeters multiplied with each other.
Yeah.
And then for the direction, you would use the electric fields for that to calculate.
For the direction of the area vector?
Yeah.
No, the direction of the area vector has nothing, regardless of what the electric field is, the direction of the area vector is dependent upon this plane right here.
Oh, so I can just ignore that until part B, which
Right.
is the flux.
Yes.
Oh,
Yes.
okay. So then I would just give the direction that it runs across. So for like this problem, would it run on YZ?
Say it again?
The direction of the area vector would run along Y and Z. Is that correct?
No. Let's flash back. If I have Y is equal to 4X plus 3.
Mm-hmm.
So it hits at 3 here, slope of 4, so crudely like that.
Mm-hmm.
Slope is 4. If I want something that's perpendicular to it, what's the slope of a perpendicular line? How would you find it?
Inverse,
And what do you mean by inverse?
or the reciprocal line,
Okay, so the reciprocal,
and then negative.
yeah. So multiplicative and additive inverse. So the slope of the perpendicular line would be negative 1/4. Now, I know the general direction now, but I have to put it in terms of a unit vector. So, the slope of negative 1/4 means that the rise over run, so my run is 4, my rise negative 1. To put this in terms of a unit vector, well, I know my hypotenuse is square root of 17 in this case. Little Pythagorean theorem. And so the unit vector cosine theta I hat plus sine theta j hat So that would be -1 over the square root of 17 I hat plus 4 over the square root of 17 j hat. That would be my unit vector.
Okay. Then we can use either or, positive or negative.
Yes.
Okay.
But do pick one or the other.
And then for electric flux, are we finding like electric flux where x is negative and when x is positive, or we're just finding one?
All right, so you're doing both. So the electric flux. All right, so formally, I guess by definition, it's E dot dA.
Yeah.
But we have we have two different constant electric fields.
Mm.
So this is basically, remember, integral is just a
Yeah.
sum. So EI. However many you have. So you're gonna be doing for half of it, one of the electric fields, and then, because it's centered at the origin.
Okay.
So you'll do E dot A for, say this part plus E dot A for that part.
Okay. So you just find two fluxes and then just find the sum of them.
Yep.
Okay.
And if one's positive, one's negative, then you're gonna add them regardless of whether they're
Mhm.
positives or negatives or mixed.
That helps a lot.
Okay. Other questions? Guess I probably should bring up that. Okay.
Master said 25.
Yes?
For Master said 25, I'm just having trouble finding electric flux for stuff that is where the charge isn't centered. So 2B, 3, and number 5, if you give an inconsistent animal of one of those, finding the flux.
Alright, so I heard 2B, 3, and 5.
Yes.
May I borrow someone's?
What do you need, Catherine?
No, I need the Master Set 25. Thank you, William. And 3. Alright. So for 2B and 5, that's just Gauss's law. If it's not centered, it becomes a lot more difficult mathematically. So I just recommend that the electric flux through a closed surface is just equal to the enclosed charge divided by epsilon sub naught. Or you could do it a really hard way, which is basically you're deriving Gauss's law from scratch.
Yeah, I was starting to go down that path. I realized that I was either doing something extremely wrong or this was not the intended route.
Yeah, the intent was Gauss's law.
And additionally, for number 3, is that because it's infinite, we can consider it centered?
You can. That in essence is deriving, I think we did that, or something similar to it. That is deriving, using Gauss's law to derive the electric field from an infinite line of charge.
So for number 2, even if the charge is not centered, the answer 2B should be the answer 2A.
I believe so.
William? Thank you.
That sounds right.
Yeah, so it's at the center and halfway between the center and one of the corners. Yeah, as long as that charge is still inside the cube.
As long as it's still inside the cube, the total flux should be the same?
Yes.
That's okay.
I didn't realize that until like staring at the textbook for 20 minutes. And I'm like, oh, that answers everything.
But some people, you know, like I was grading the master set 23 and problem number 1. Some people decided to do, instead of looking it up and using the integral tables, decided to do trig substitution. Nothing wrong with that, other than it takes longer.
Dang, I could save myself some time. I was thinking the same thing. I thought that would be one of the show your work kind of things. Oh, you know how to do calc too, but
Now it was in there just the idea, the hope was that people would just do the integral tables, but some people just like showing off and showing that they can do trig substitution, fine, that works.
I'd rather not.
Other questions?
So for, when you're finding the charge at a certain point, but at that point, the charge is already there, or, sorry, how am I supposed to word this? When you're finding the charge at, on number 5 at Q2, and you take in the electric fields from 3 and Q3 and Q1, do you take that electric field and add the charge of Q2?
So the first, so like you have Q1, Q2, and Q3. I ask you to find what is the electric field at Q2, wherever Q2 is.
Well, you asked us to find the flux, so I'm at Q2, so.
Okay.
So find the charge at, Q2.
I think I'm gonna have to look at, that's problem number 5.
Yes.
Thank you, William. Let's see. So you got the 2 charges there. They're fixed. So this is just purely electric flux. Oop. Earthquake. I guess I can move it a little bit closer. All right, so they are 20. All right, so Pat, what is your question again?
When you're finding the charge at Q2, do you account for the electric field produced by Q3 and Q1?
This is again a Gauss's law thing. So once you figure out where Q2 is roughly, because the 5 nanocoulomb would be placed closer to the 3 coulomb than the negative 8 coulomb. And so an additional negative charge is placed. Oh, wait, no, wait, sorry. That negative charge would be not in between them, it would be outside of them.
Mm-hmm.
That negative charge would be to the left of the 3 coulomb charge. So the Gaussian sphere, which surrounds Q2, which is the negative 8 Coulomb, yeah, you would take that into account. Again, the total electric flux through that through the surface of that sphere, Q1 and Q3 are outside of it, so using Gauss's law, it wouldn't matter. They are irrelevant.
Okay, thank you.
Yep. I might be back, of course.
How would you go about like solving those problems without Gauss's law? Wouldn't it just be like a nightmare in its own right?
Well, in this particular case, I believe the sphere was centered at where Q2 is.
Yeah.
So in that case, you got some nice spherical symmetry. So I'm some distance r away. I know that the magnitude of my electric field from this charge right here would be the same no matter where I am. Oh, wait a second. So the electric flux coming from that charge at the center is relatively simple. Because my area vector here is in the same direction as my electric field. My electric field is a 1 over r squared relationship, while my surface area is an r squared relationship, so the r squareds cancel out. However, to take into account the stuff that's outside, you would use divergence theorem, or I'm just trying to think of doing it with just Calc 2. Because I have an electric field coming in, I have an electric flux going into it here and coming out of it here. So the electric field is stronger here than here. Yeah, it'd just be a big pain in the butt. Yeah, I don't think I've actually worked it out. I believe that was your question, right? Taking all of it into account?
Yeah.
Yeah, that, the one in the center, that's relatively